Hello students, this is the answer key for exercise set for chapter 5. And here's the first problem. An urn contains 4 red balls, 3 blue balls, 2 green balls and 1 brown ball. 1 ball is selected at random. Consider the game X defined as follows, and here is the rule. If you get a red ball, then you have to pay $5. If you get a blue ball, then you win $1. If you get a green ball, then you win $2.50. And if you get a brown ball, you win $10. That's your lucky day. Now, based upon this rule, you have to answer these questions. Find the probabilities that this game yields payoff value strictly greater than 1 versus greater than or equal to 1. There's a subtle difference. Next, find the expected value. Do you remember the expected value formula? If you don't, now is good time to review it. Same for the probability standard deviation. Variance and its square root is standard deviation, but how do you find those? Well, maybe it's a good idea to stop this recording and look up the formulas. And finally, cumulative distribution function. This is the hardest and not coincidentally more important. Alright, before doing anything, however, let's find out the mass function. What is the mass function? And the probability values for each possible x value. And one way to express it is here, this way. The table form. Excuse me. Let me restructure this. Here is one way to here's one way to express it, the table form. And it's very similar to the original, but instead of color, we have all the possible x values up here, and down here we have probabilities. Why 4/10? Because there are 4 red balls out of total 10 balls. And next, why do we have 3/10? Of course, there are 3 blue balls to choose from out of total 10, and so on and so forth. That's how you get the probabilities. And this table form is the most preferred form of the answer according to our textbook authors. And there are some benefits, of course. Here is an equivalent expression. The piecewise defined function. Structured kind of like this. In the right hand side, put all the possible x value. X is equal to -5, x is equal to 1, x is equal to 2.5, x is equal to 10. Yes, all these values. Now, is there anything else that is possible? No, there are only 4 colors here in this urn. Only 10 balls. So otherwise impossible. So that probability is 0. And for x values -5, 1, 2.5, and 10, you just find out probabilities the same way. 4 out of 10, 3 out of 10, 2 out of 10, and so on. And here I use decimal form, but it's okay to use fraction form. And the same goes over here. You can use decimal form here if you want to. Anyway, there are 2 types of equivalent way to express the mass function. And this is preferred by our textbook authors and most of my students in past. And if things are the same, well, this semester too, I believe most students would prefer this one. Personally though, I prefer the next one. Maybe that's because I'm not a statistician, I'm a mathematician. And the student who has some background in higher math like calculus and must be really familiar with this piecewise defined function format. Anyway, we talked about mass functions, so let's come back and answer these questions. the probability for x strictly greater than 1, you have to have either green or brown, so we just add up the probabilities. I color-coded, so it's easy to see which is which. Now x is greater than or equal to 1. In this case, you have to have 3 possible colors, blue, green, or brown. So we add up 3 probabilities. I color-coded, so it's easy to see which is which. Okay, that was easy. Now let's go to the expected value. And this is the expected value formula. Sum of x times p. So possible x value times the probability for that, and sum them all up. So what do you mean by that? As a matter of fact, let me copy and paste the mass function. That's going to be a bit more convenient than the original problem here. So, okay, here's a mass function, all right? And then possible x value, -5 times the probability. Next possible x value times the probability. Third possible x value times the probability. And finally, fourth possible x value times the probability. Adding them all up, we get the expected value. I have color-coded everything, so it's easy to see which is which. This is my preferred way, using the formula sum of x times p. Now, a lot of students prefer an algorithmic approach like this. Here is the mass function, first 2 rows, x value and probabilities. And for each column, we just multiply. So we get that. We just multiply, so we get that. Just multiply, we get the product. Multiply, we get the product. And then what do? We add up all the products, as we see over here. So this is rather algorithmic than formula. So it's a little bit difficult to express this algorithm in single line like this. So personally, I prefer the formula method. It's easier to memorize, and I have a lot of experience with formulas, so I don't really have difficulty doing this. But if you do have difficulty manipulating or applying formulas, then maybe it's a good idea to practice this algorithmic approach. Get the mass function like this table. First 2 rows is the mass function, and then get product, 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 and then add them up, and that's the expected value. Alright, next let's talk about the probability standard deviation, and that begins with expected value we calculated early on. Expected value, which we call mu, is -0.2. You're losing about 20 cents each time you play. Not absolutely, of course, it's give or take, but on the average or expected loss is about 20 cents. That's your mu, and here is the variance formula. X value minus that mu and square it to make it positive. This thing is called deviation, and deviation squared times the probability. So how do you apply? The first x value is -5 minus mu and squared times the probability. Do it again. Second x value is 1 minus mu squared times the probability. Next, x minus mu squared times the probability, and just goes on. X minus mu squared times the probability. All those, punch your calculator in, you get 21.51 in this case. Taking the square root of the variance, you get what you want in the end, the probability standard deviation. Okay, finally, let's talk about the cumulative distribution function. What is so-called cumulative distribution function? It's defined like this. Oops, this should be parenthesis. So capital F of x is defined by the probability that this game yields less than or equal to x. So for example, what if you have 2.4? The probability that x is yielding a value less than or equal to 2.4, well, we have to consider these two, red or blue. So this is 0.4 plus 0.3 equals 0.7. What if you increase this into 2.499? The probability that x yields less than or equal to 2.499, again, just these two, so same computation holds. But all of a sudden, when this hits 2.5, it's no longer two cases because green now kicks in. So, oops. So the new probability is 9. So as you see, the cumulative distribution function has some jumps, and that jump takes place at possible x values of the mass function. In the end, you get something like this. Here's a mass function, and we get these x values, -5, 1, 2.5, and 10.0. And these 4 x values divide your number line into 5 pieces. Less than -5, so less than this one, between -5 and 1, and then from 1 to 2.5, from 2.5 to 10, and finally greater than or equal to 10, as you see over here. This right-hand side is far more important and trickier than the left-hand side. Most of the mistakes I see, by the way, I see a lot of mistakes each semester, and most of the mistakes come from here in the right-hand side. All those breaking values are coming from the possible x values. Right here. There are 1, 2, 3, 4 breaking values. So we have 1 from line 1 and 2, 2 from line 2 and 3, breaking point 3 from line 2 and 3, 3 and 4, excuse me, and finally breaking point 4 comes from breaking point number 4 comes to line 4 and 5. That's the structure. And if I have different numbers here, different payoff values here, the structure remains the same. These numbers will have to change accordingly. This one and that one are the same, but it may change to something else accordingly. And you may have to add some more lines, or you may have to remove some more lines, but those are minor adjustments. The key part is right-hand side here. And once the right-hand side is set, left-hand side is much easier. Less than 85, that's impossible, so probability always begins from 0. Next, 0.410. 0 plus 4/10, excuse me, this is cumulative, so you have to add up. Next, 4/10 was a previous probability, so you add up the next probability, so we get appropriate addition or accumulation. Next breaking, we have 2.5 and the probability is 2/10, so that's added here. So adding all these up, you get accumulation. Finally, at the last breaking point, you have this probability, so add up all those, and these will add up to 1. So everything begins from 0 and ends at 1. Yeah, here's a little bit simpler version. Well, 0 to 1, and then I simplify them, but of course, And you don't have to use decimal, you can use fractions if you want to, but in any case, here simplified version, but in any case, the right hand side stays the same, and that part is the key. I emphasize again, it's the right hand side that is more important, the if part. And here, the left hand side is semi-inequalities, and then x. And then right hand side is strict inequality, and there, right hand side of x, strict inequality. Please remember this entire structure, that never changes. Once you get used to this right hand side, you can answer these kind of questions easily. Also, you can do a backward problem easily. Okay, I take it back, not so easily, but you'll be able to do backward problem like problem 2 as well if you get used to this right hand side. Okay, so much for problem number 1, and the other problems will be discussed in separate videos.